Now that we're done the upright, you already know everything that you need to know to make the base. You're going to be able to work pretty independently for this one because it's all the stuff that we've already done to draw the headstone. So we're going to go through this one much faster. In terms of learning, we've covered everything that we wanted to teach you in our introductory CAD lesson except for assembly. So this is just practicing what you've learned. But to do any assembly, we're going to have to actually design the base first so that we've got something to assemble. File, New, Part. Okay, grab a plane. Extruded base. And now I stop talking while you guys apply what you've already learned. So you've got it done now. You'll see here that when I put the resolution way up, it doesn't really make any difference because these are all straight lines, so they're not going to go into more segments like a curve would. And over here, I'll go with perspective because it just kind of looks funny right now. So we've got our base done. We need to save it because our assembly file doesn't actually import the parts. It just keeps track of the positional relationship between the parts. For an assembly file to reference a part, we first have to save the part file. I'm going to call it Teaching Document Base. I haven't done it yet, so I'll name the groove for our tongue and groove construction, and we'll make this a nice pretty green color to match the top. So, okay, pick a name. Save, done, at least for now. We might round these corners, but we may as well put it together first to see what it looks like. File, New. This time we're going to pick an assembly. Because both of the files we need are open, they're going to show up right here in this toolbox as open documents. If they weren't open, we'd go and browse and we'd find them in our folders and bring them into the assembly that way. The first part that we add to an assembly is going to be stationary. Any subsequent parts brought in will move relative to it. So we'll bring in the base first, just because it visually makes a little more sense. To bring it into the assembly, first we click on it once over on the left. We then move our mouse over here and we click again and right. It's now in the assembly. To bring our upright into the assembly, we have to go back to Insert Components, then grab Teaching Document Lesson 1, which is our upright. I'll drop it here. Now you notice I didn't try to physically put it in place right now, and the reason is that we're actually going to use references called mates to locate it relative to the other parts. Putting it in place before we do that can make it hard to choose the surfaces that we need to set up these mates. So what's a mate, you ask? So a mate in the context of engineering has nothing to do with National Geographic. It's a positional relationship between two entities or two objects. Right. So if we selected, say, the corner of this piece here, specifically that point on the corner, if we were to mate that to this other corner here, those two corners would then have to touch at all times from then on because they have a coincident mate. They must be in the same place at the same time. The parts could flop around and they could spin and do lots of reorientations relative to each other, but they couldn't move such that the points weren't touching anymore because of that mate relationship that we've set. If we were to mate a face to another face, then those two faces have to be coplanar to one another from then on. They don't actually have to stay right on top of one another or even touching one another, but they have to be on the same plane all the time, even if one part is far away from the other part. A plane to something mate is a little bit like our line to something mate was in dimensioning. The mate will control the distance normal to the plane selected between that plane and the second entity that you select. There are several types of mates that we can use. The most common is the coincident mate, which means that the two entities must be touching. There's also a distance mate, which sets a set distance between them. If we use the latter for a plane-to-plane mate, one face will be on one plane, and the other face will be on a parallel plane, a set distance from that first plane. The next most common mate that we'll use is a concentric mate. In a concentric mate, cylindrical features are positioned such that they are coaxial to one another. Back to our plane-to-plane coincident mate. This mate moves the parts along an axis normal to the planes of the selected faces, so that these faces are now coplanar. You can slide the second part around that plane and you can rotate it, but you can't lift it off the plane. 1 degree of freedom is controlled. If you then add a plane-to-plane mate between the side of the part normal to the first plane and to a plane on the other part that is also normal to that first plane, the part will move so that the second pair of planes is also coplanar. The part is now locked from moving normal to the plane of this second mate, and it still can't move normal to the plane of the first mate. In addition, it's now impossible for it to rotate on any axis without ceasing to be coplanar with the second mate. This leaves us with freedom of motion in only one remaining direction, along the plane of the second mate. To lock this axis, we set a face normal to this axis on each of the parts. The relative positions are now fully locked in. It's impossible for any relative movement to happen between these parts without one of these coplanar relations being violated. Sometimes when you select a face-to-face mate, the surface is lined up with the right surface on the other part, but it's on the wrong side of it. To fix this problem, you can select Flip Mate Alignment in the Mate toolbox. This will reverse the orientation of the parts on the plane. Okay, so we'll close up our mate toolbox. These parts are now assembled, but we've got nice round corners on the upright and we've got these kind of square corners in the base. This bothers me. So we have two choices. We can go down here to the bottom of our screen and we can hover over these minimized tabs until we see a preview of the base. We can then click on it, it'll open up, and we can edit it like normal. We can then put fillets into the part drawing, returning to the assembly via the same method to see how they look afterwards. Or if we want to save a little bit of clicking and switching back and forth, we can stay in our assembly document and do it here. But before we do, I'm just going to save the assembly. Save all, and we will call this Teaching Document Assembly. We can't modify the parts within an unsaved assembly. Okay, now what we can do is we can select our base in our view window or our directory tree, and then select Edit Component from the very left hand of our toolbox. Look what comes open, all of our regular 3D tools. So I select Fillet here, and I select my corner edges, and I can put the fillets in the corners. I'll go with 15 because I've got the conic row on the upright, and I think it'll work well together. And that looks pretty good to me. Actually, no, I'll bring it to 20. That looks nice, so I'll say yes, and I'm going to turn off the Edit Component tool. Sure enough, that looks good and the fillets are in place. What's nice is that they've also been inserted to our original base part document. So when we edit component, it's really happening in the parts drawing even though we're doing the actions within the assembly, which is pretty neat. So the cool part is that your edits in your assembly and your parts are interactive. They go either direction. That's really helpful because sometimes you can assemble something without actually lining it up. Then you can line up everything and do your edits within the assembly. All of your holes, all of your pegs, or whatever you need to line up or place in the right spot will be right in the right place on both drawings. So I can name that feature, and I'll go with corner fillets. Well, that's it. You've designed and assembled your very first SolidWorks assembly. Everything that we've covered up to this point will give you the skills to make most of the usual types of items that students make here in the lab. There are other tools and techniques that we can leverage for more specialized purposes, but this should give you a base that you can build on that's solid enough that even if our staff wasn't available to help you out, you could go along until you got stuck, reference from videos from the internet, and move yourself forward. Without this basic lesson under your belt, for a lot of people, if you tried this, you might get stuck to the point where even videos can't get you unstuck. So that's it for our first introductory SolidWorks and very basic designing lesson. We'll see those of you that want to make parts and assemblies with more complex shapes and go further in our more advanced lesson series. Hopefully we'll see the rest of you using these basic design tools here in the Science Maker Lab to make some really cool stuff. Thanks, and enjoy your new skills.